Assalamualaikum warahmatullahi wabarakatuh. My name is Hariz with ZAHRULLAIL and my metric number is 01DGT12F1029. So today I will do some demonstration and explanation on this practical exercise. So based on this question given, I have been assigned and do all of this question, which is we have to assign this IP address for each device, and based on in table 1 we have also configured the direct connected static route on RTA, RTB and RTC, and we have to configure some default static route on an ISP. So for this demonstration, I will show you how it works and explanation why. So for this, we have to check first if I have assigned all of this IP or not. So let's check out on RTB first. So for the RTB, I have assigned boost of IP v6 and v4 to gigabit 00, which is this network. And then for serial 00, I have assigned this IP on this network, which is this connection. And then that's all for the IP configuration. Let's check on RTC. So for the RTC, I also done configure all of this IP address, which is 172.16.5.1 slash 26. So for the subnet mask is like this, 192. So this is for serial 001 that assigned for 172.16.2.1 with prefix length by 30. Now let's take a look on RTA. So for the RTA, let's check first. For the RTA IP configuration on the Gigabit Ethernet, we have 172.16.6.1, which is for this interface with a prefix length 62. This network this network for this interface. So let's check on serial 00, which is this connection to RTB. I have assigned 172.16.1.2 by a prefix length 30. Also IP address v6, which is it use fate :1 :2 /64. So some same of this I have prefer on this addressing table and for this information also. So for the next on the ISP, let's check. So for the ISP, I have configuration also IPv6 and IPv4. Alright, now let's take a look on this demonstration and explanation. So for this direct connected static route, we have to configure. For example, I configure from this router, which is RTB. So the direct connected network is we have to assign a remote network, which is have a not direct connected. The direct connected network is based on this easy interface that has we use. So for this example, I will open my term configuration and we have to see this configuration for IPv4 connected route. So for this 172.16.5.0, I choose from this network, which is from Gigabyte RTC. And then this is for subnet mask that has been used for this network, which is 192 slash in the subnet mask by prefix length. We define it as a 26 in the prefix length. So for the serial that has been used, we have to configure easy interface from RTB router. So if you can see, I have done one line of configuration for this network. So we have to assign 1, 2, 3, 4, and 5 others of network to by using this easy interface. So for this, we have a 172.16.2, which is from this network. By so for the prefix line, we have a 3252, and then we have to assign 172.16.6 from this network, which is the use of for 26 of a prefix length. But in subnet mask, we use a 192. So for this network, we configure from this IP, which is from this network that connected to the ISP on the net. And then for the last, we have IP route here from the 10.10.10.0, which is from this network. So for this network, is especially to use /28, which is in the subnet mask. We define it as 240. So for the all of easy interface, we just configure by using this RTB easy interface. So that's all from RTB direct connected network. Now let's take a look for the IPv6 on this RTB. So for the IPv6 route, direct connected static route, I have a configure for this network, which is 201 db8 fed :5 double colon /64 by serial 000 as an easy interface. So for this, we have pick from this network, fed :2 from this network, fed.6 from this network, cat :1 from this network, and cat2 from this network. So for all of this IPv6 route, it's the same as the IPv4 that has been configured by using serial 00 because it that we configure from this RTB. Now let's take a look on this RTC. So for this RTC, for IPv6 route, I have configured from this by using IP address 172.16.4.0 from this network by easy interface or direct connected network serial 001. So to identify this directly connected network, we have to see the easy interface of this router. So let me see. Yep, it is serial 001. So my configuration, all of this configuration IPv4 and IPv6 is true. Now let's take a look on RTA. So for the RTA, we just configure some of network because this is a direct connected network. But for this case, we have to pick a remote network, and for the direct connected, we have to define the as a easy interface. So we just have a three network that has not connected or direct connected to a router, which is 172.16.4.0, which is this network. There is no connected directly to this router, so we can use this to assign the IP address. So for this 16.5.0 from this network, which is same as 4.0, not connected at all, and then we have a last IP route here 10.10.10.0, which is from this connection. So you can see there's all of this IP that's not direct connected network, but we define by this easy interface it's just considered for direct connected network. And then it's also same for the IPv6 that I have configured here, which is 000, 0001, 0010. So for the 000 is just like from this, if we configure for this network, we have to use this easy interface which is 000, and if you configure from this network, we have to choose this easy interface as a serial 001 as an easy interface. And then for the last, we have to pick 0010, which is from this easy interface, because it uh, it is from this connection or one way. So we just use this easy interface as a direct connection. Now let's move for the routing table, which is routing table that has been updated since we configure IP address on this router. So we started from RTA. We have to put this command show IP route for IPv4. Let's see the connected or routing table here. So routing table here shown all of these connected that has successful. It will be green connected. So the connected that we can define or detect here, which is C symbol. C symbol for in the packet tracer is defined for direct connected. So for this IP address, it's direct connected by the serial 001, which is from this network. And then we have another direct connected network, which is from serial 001, which is IP address 172.16.2.0. So it's from this configuration that we configured before. And then we also have a 172.16.6.0 by gigabyte 00, which is this connection. So for the next, we have another, which is 200, 203, 203, 203.0 dash 30, which is direct connected network by serial 010. So let's check out for IPv4, IPv6. So for the IPv6, we have to configure just this way. So the routing table has been updated successfully. Now let's see if we put the connection in administratively down and see what happens. So we just put the connection in down. We have to put the connection that we have to down. Shut. Also one left. 0, 1. So let's see back the routing table. So as you can see here, there's no one connected or status in the routing table. So we cannot ping from this device to web server at all. But if we turn it back on state to up, it will automatically can update, the router can update the routing table back. So we just config back. Alright, so as you can see here, the connection turn screen right now. So we can ping from this end device to this web server. So just like other, if we turn one off connection here, it will cannot run or forward the packet smoothly. It will be dropped at somewhere that we have to do some troubleshoot. Now I will show on this ISP that has we configured as a boot default static route by configuring IPv4 and IPv6 default route next hop route in ISP. So on this ISP we have just configure IP default route, and let's see how it goes. So for the command is that same, just like same show IP route. This is represent for the IPv4. So for this routing table that has been updated by this router, we have two direct connected, which is 10.10.10/28 that connected to gigabyte 00, which is this network. And then we have one more, which is 203.203.0/30 by connected 0010, which is this easy interface. All right. So for especially for this ISP router, we have to configure uh, the IP static default route, which is 0000/0. Then we have to put the network have been assigned as a default IP route. So the symbol for this IP default route represent here for this is asterisk. Asterisk is represent the IP default route has been configured. Now let's move for the best path determination. So best path determination is also known as a longest match that has to meet the requirement of matching by IP address between subnet mask or prefix length. So to check this out, we have to identify the path that we can see from the prefix length. So the currently that we use in this topology or network, we use 26 as a prefix length. So for in the subnet mask, we have the 255, 255, 255, 192. So to meet this requirement, the source and the destination have to encapsulate the frame that contain the MAC address. So to check this out, I will do some demonstrate on this PCC2 to PCB2. So we can see the path that has determined by this router. So for the determination of path, the router is considered to give the decision based on the information in the routing table, since the routing table are updated. So to check the determination to the PCB2, we have to test it. So we use the test command in the command prompt, and then we have to put the target IP. So we choose 172.16.4.10. Alright, so we have successful reset or ping to the end device PCB2 by using this network, which is 172.16.4.0. So as you can see, the trace route has been successful, which is the router has determined the path by using this command or information here, 172.16.5.1, which is from this interface, easy interface. And then for the next we have 172.16.2.2, which is at this easy interface. For the number 3, we have information, the path in 172.16.1.1, which is from this easy interface. So the 1, 2, 3 determination that will start from this PC to RTA. And then he will arrive now at the degrees for the easy interface in RTA 0000. Now for the last, to reach this destination, the router at this RTA determine the best path by using this link serial, which is 172.16.4.10. The packet has been forwarded by the RTA until the reach at this router, and then the router gives the access based on the longest bit requirement. Then this destination or target host is successful. Now let's see for the another forwarding packet, which is I have to demonstrate from this PCC2 to PCA1 that link by serial 001. Now I will test it out first to check the forwarding. So for the forwarding packet, the set has been determined by this router based on the information on this routing table. The path that has been used to forward the packet, they use is easy interface on this gigabyte Ethernet 00, which is 172.16.5.0, which is this easy interface at the RTC. Now the forwarding packet based on the longest meet requirement, the packet forward through the 172.16.2.2, which is at this link serial interface. So the packet has been arrived here, and then for the last accessible to reach the destination, they use 172.16.6.0. So since this is a gigabyte Ethernet, the forwarding packet has been through since the routing table has been updated in this RTA to use this path to meet the destination. Now let's see for the IPv6. For the IPv6, I will just do in the same PC, so I will can ping easily to another destination. So I will ping to the web server, which is this. Now I will use 201 dba kate dot colon double colon 2 slash 64. Now as you can see here, the trace route has been successful. So the forwarding packet decision by this router, the path is determined to reach at this easy interface, which is 5 colon 1. 5 colon 1 is in this interface. Then we forward to fate 2 colon 2, which is at this easy interface. Then we reach at this destination, which is at Kate 1 colon 1, which is at this. We will have to wait for this process in the translation route will have take time. So this never mind. This will stop at this 13 hops. So now let's see for the calculation. For this calculation, the requirement that we have to match between IP address and the subnet mask, we have to compare the prefix length, which is 20C. When I want to ping from this network, which is from 172.16.5.0/26, the meet of requirement based on this network, they have to meet the requirement on a routing table that has been updated to use the best path selection. So if we ping from this, it will check the bit of file length that have to meet or match for the requirement to check if the IP address that from the source is same in network or not. So if same, it will give a permission to forward the packet to other destination or router. So for the IPv6 calculation, it's also same just like IPv4 concept. It's little bit different that compared to IPv4. The bit of requirement 64 bit, we have to compare the another bit which is at IP address. Since the IP address is set at maximum of which is 128, the bit have to find the longest match to consider it will consisting on this network that can be connected. In addition, the best path that have been determined for this router based on the link or connection that we use in this topology. So back to previous, the topology that we use is a small topology. So and the concept that we use are direct connected network. So the direct connected network has a AD value which is 0. So to meet the requirement, the direct connected network value in this topology is totally 0. As you can see here, this the configuration of the direct connect that have been configured, which is from this link serial 000 and also 0001 and also 0010. So based on this configuration, we know the value of the connection is 0 by default. For the longest match or the best path, it will choose for 0 as a best path consists there's a no value or another value in this connection. It will consider to use 0 as a path to meet the requirement of bit by the prefix length. So for this topology, this is a real connection that indicate value as 0, but for this ISP router that have a hidden internet hidden router in here, the static route that we configure, default static route that we configure, it will indicate value as 1. It is because the administration distance table that told the value is 1. So we just use the default as 1 to determine the path that is considered to be forwarding the packet. So the frame has to be encapsulated at the router. Consider where the packet has been forwarded to meet the requirement of the longest match of path.